Chapter 1, Section 1 is all about variables and expressions. By the end of this lesson, you should be able to write an algebraic expression or a function rule, which is an equation, using variables. Okay, to start with, they're going to give you this question. Consider the population of Florida, the area of Colorado, and the flight time from Philadelphia to San Francisco. Which of these has a value that varies? Okay, well, in order to do that, you probably need to know what these words mean. So varies is going to be one of our vocab words. Okay, over here. Variable, like we were just talking about, is a symbol that represents the value of a variable quantity. Okay, that means that a number that could be different depending on the situation, instead of putting a number there, since we don't have a concrete number, we actually take that number out and we put in a letter or a symbol. Quantity is anything that can actually be measured or counted. So that is a number. One number every time. If there's 5 marbles on the table, it's just a 5. Okay, so that means if I look back at this first question, which of these could have a different number depending on the situation? The population of Florida, that definitely could change depending on how many people move in and how many people move out. So I would say that one could be variable. The area of Colorado, that's pretty set. That's definitely not a variable. And the flight time from Philadelphia to San Francisco, maybe, depending on weather. So I would say those have values that vary. The next two vocab words are algebraic expression and numerical phrase. Algebraic expression is one that math sentence that has variables. A numerical phrase is a math sentence that has no variables. Okay, in your notes packet, the next thing that they show you is an area where we need to write down words that mean add, subtract, multiply, and divide. When you're reading algebraic expressions, you need to be able to know what they're asking you to do. So we're going to brainstorm and try to write down words that would tell you that you need to add, subtract, multiply, or divide. Okay, so take a second in your notes and try to brainstorm some words that you would read and know that you need to add. Then come back and check out if you have the same words that I do. Okay, some of the words that I thought of when I was thinking about adding would be if I saw the word sum, if I saw the word plus, if I saw more than, if I saw the word total or altogether. Hey, you might have thought of more. If you did, let me know what you've got. Okay, for subtract, I thought of less than, difference, minus, and this symbol. For multiply, I had times and product, but this one had more symbols. This one had the parentheses, the dot, the asterisk, and we used to use the x, but we don't use that one anymore in algebra since now we use x as a variable. For divide, this one gets tougher. This one I just had quotient. Sometimes if you think of splitting things into groups, you would divide things up. And the symbols for that one, we have the line between two dots, we have the house, the slash, and the fraction bar. Those all mean divide. All right, grouping symbols. When they say grouping symbols, they mean like parentheses, brackets, like that, like this. And I'll give you some examples of words that will help you once we get into the next. Turnaround words, sometimes you need to look twice. And there are some words that tell you instead of writing it exactly how the sentence says it, you need to actually flip it around. Those examples will come up. Okay, what is an algebraic expression for each word phrase? So they wrote these math sentences out in words. They want you to write it as an actual math sentence instead of words. And these are gonna, because they're algebraic, they're going to have a variable in it. So what I always try to do is I just go in order. So 32, that doesn't change. More than was in our list for adding. A number x Okay, so already done. 32 plus x is the same as 32 more than a number x. Okay, twice. That means 2 times a number y. So 2 times y, which is the same as 2y. 58 less than means subtracting a number. If they don't give me the variable, I can come up with my own. But now this less than, this is one of those turnaround words. If I want 58 less than a number, I don't want to, this is not the right order. We actually want to separate, or flip this one around, turn it around. X minus 58. I actually want 58 less than the x. Okay, so there's your turnaround word, less than. The second one is another example of subtraction, but without the turnaround. 100 less than, 100 less a number n. Okay, so I have 100 and I want to make it less by the amount of n. Okay, so less than was turnaround, just less was not. All right, why don't you pause, go ahead, try these couple on your own, and then come back and check your work. Eight plus the sum of a number and 10. So I'm actually adding 8 to whatever a number and 10 are added together. So that is an example of a grouping symbol word. Okay, the sum of 3 more than twice a number x. 9 less than, okay, so we know that 9 is actually not going to go first. The quotient of 6 and a number is what's going to go first. So 6 divided by a number, and then minus 9. The product, which means multiplication, of 4 and the sum of, okay, so that means I need parentheses, number x and 7. Which would also be written like this. Okay, now they're going to switch it around on you and they're going to give you the math sentence and they want you to write the words. There are a lot of different options, but as long as your words make sense with the math phrase, it will be good enough. Okay, so 3 times x, we could actually just write 3 times x. How about this one? 5 times the difference of n and 2. Go ahead and try these 4 on your own. All right, last but not least, we're going to check a couple word problems. The table below shows how the height above the floor of a house of cards depends on the number of levels. What is the rule for the height? Give the rule in words and as an algebraic expression. All right, well, they almost show it as an algebraic expression for us, but there's no variable. The only number that changes is this number right here, so that's where we're going to stick a variable. Okay, so it's going to be 3.5 for our algebraic expression times the variable plus 24. Okay, well, in words, I'm going to say 24 plus the product of 3.5 and the variable n. Okay, this table shows how the cost of renting a scooter depends on how long the scooter is rented. What is the rule for the total cost? Give the rule in words and as an algebraic expression. Okay, well, it looks like after the first hour, we've paid $17.50. From there, we add another $7.50 to get to 25, and then we add another $7.50, and so on and so forth. Okay, so every time we're adding $7.50. That means each hour is $7.50, but in order to even rent this, if I take $7.50 away from the first hour, I had to pay $10 just to start. So I have to pay $10 no matter what, plus $7.50 times however many hours I'm using it. That is the algebraic expression. In words, I would say 10 plus the product of $7.50 and the number of hours, X. Okay, your assignment is going to be on page 7 in the book, numbers 10 through 38, only the evens, then numbers 39 and 40, 45, and 47 and 48, along with your lesson quiz that all can be found on Google Classroom. If you have any questions, make sure you contact me.